So now that we know what an inverse function does, and we know how to find the graph of an inverse function based on the graph of the original function, how can we actually find the rule for an inverse function for a given function? That's what example 3 asks us to do. And as you look at the back side of the handout, I've given you a 4-step process that we're going to follow. So once again, you might want to go ahead and pause the video, read through those 4 steps, and then we'll move forward. So as you look at example 3a, once again, they're telling us that they've given us a function f that is 1 to 1. And because f is 1 to 1, that means that we're actually going to be able to find an inverse. So let's go ahead and go through the 4-step process and find the inverse for this function f. So step number 1 is not actually a new idea. We know that f of x and y are going to be the same thing. So we just use old ideas and replace the f of x with the variable y. Now, step number 2 is the main item that we talked about in the previous example. That if you're looking at a function f and the function f inverse, you know that the a and the b, the x and the y, are going to swap places. So AB is on the graph of f, BA is on the graph of f inverse. So XY is on the graph of f, that means YX is going to be on the graph of f inverse. So step number 2 says, okay, just interchange the x and the y if we're going to be looking at the inverse then. So y is going to become x, and x is going to become y. So now that we've done that then, as you look at this problem, it's a reasonable next step then to say, well, if we're looking at a function, traditionally we have y equals. So what we want to do is take this expression that we now have and solve this equation for y. So in order to solve for y, we need to figure out what's hanging out with this y and how we can undo that. Now, using the order of operations, you have to be a little bit careful and make sure that you are undoing things in a reasonable manner. So we have a cube root, we have a multiplication times 5, and we have that subtraction of 1. I can't go in and just do these in any order that I want, so I have to be kind of careful about the order in which I do this. You'll notice that the entire right-hand side is associated with that cube root. And because that entire right-hand side is associated with the cube root, that's the first thing that I want to focus my attention on. I want to undo that cube root. Take both sides to the power 3, and that'll do that. So if I take the left-hand side to the power 3, we're going to get x to the 3rd. And if I take the right-hand side to the power 3, the cube root and the cube undo each other, and we get 5y minus 1. Now that we have this then, the next thing that I'm going to undo on the right-hand side is that subtraction. To undo a subtraction, I'm going to add. So let's add 1 to both sides. And then finally, I can divide both sides by 5. So I'm going to do that in the second column. So we have y is equal to, and then divide this entire left, x to the 3rd plus 1, by 5. So now that we've done that then, we're ready for our 4th step. Our 4th step then says, oh, in this problem they were asking us to find a rule for a new function. And that new function is f inverse. So we're going to essentially undo what we did here in step 1. We're going to go back to functional notation. But you have to be careful on this one. We can't go to the function f because that's not what we have anymore. We have the function f inverse. So the final step, step number 4, is to replace this y with the new and improved function f inverse. So we have f inverse of x is equal to x cubed plus 1, all divided by 5. And at this point then, we have finished the process of finding that f inverse. However, the directions then say, okay, now that you've gone through this process and you've found f inverse, let's go ahead and talk about some domains and ranges. Now, as you think about what we talked about earlier on the handout, when you have the domain of f, that is in fact exactly the same as the range of f inverse. So on your handout, you're going to notice I have a little spot that says domain of f equals range of f inverse. So what we have to decide is which one of those is easier to find. And once we have determined which one's easier to find, we'll find that, and then we have the other one for free. Well, if you think back to things that we did earlier in the course, we found a whole section about finding domains of functions. So it's easier to find the domain of a function than it is to find the range. So what I'm going to do is find the domain of f. And once I find the domain of f, I know that that's exactly the same set as the range of f inverse. So I'm just going to put the comment that this is equal to the range of f inverse. But again, I'm finding the domain. So let's go ahead and see what we see. Go back to the original function f. Original function f is the cube root of somebody. Well, thinking about the domain ideas we talked about earlier in the semester, I know that there are two things I have to worry about for domains. I can't take the square root of a negative number. Well, I'm not taking a square root here. And I have to worry about division by 0. There isn't any division here in the world of f. So my domain of f is going to be all real numbers. Lots of different ways of writing that. I'm going to go ahead and use interval notation. So the domain of f, all real numbers. Now once again, I calculated in terms of the domain of f, but I got the range of f inverse then for free. The range of f inverse has to be the same set, which means that the range of f inverse is also going to be all real numbers. So now that I have that information, the other two sets that they request are the range of f and the domain of f inverse. And once again, the question is, which of those is going to be easier to find? Again, the answer is the domain. So even though the range of f is written first, that's not the easiest one to find. The easiest one to find is the domain of f inverse. So if I find the domain of f of inverse, I then get the range of f for free. Well, this time I need to look at this rule that we just found. So the rule that we just found is that f inverse of x is equal to x cubed plus 1 divided by 5. Well, again, when we're thinking about the domain of f inverse, we have to worry about square roots, don't have any of those, and we have to worry about dividing by 0. In this case, the denominator is 5. I'm never going to divide by 0. So the domain of f inverse is all real numbers. And one more time, I found the domain of f inverse, but that tells me the range of f for free. So the range of f is also the set of all real numbers.